And the microphone's still working. So this is COMP2068. Kind of lost track of what week this is, but I think it's week 10, yeah. So as I was saying just before I hit record, today we're going to be going over React. So the reason why I say that React is one of the most employable technologies right now is it is used across almost any industry that is using tech. You'll go into some places and on a server standpoint, they might be using Ruby on Rails, they might be using Node.js, they might be using PHP, C#, Java. All of these are perfectly valid backends. But as you know, it doesn't matter what technology you're using on the back end, you will always end up using some form of HTML on the front end to display a user interface to the user. So in traditional, or actually, I guess I'll just go over the assignment, and then if you want to piece out, then do so. I'll continue to go on React after I go over the assignment. But anyway, I do encourage you to hopefully enjoy React. I think it's my favorite thing to use. But yeah. So okay, so assignment 2. There's kind of 3 different options that you can pick and choose from. Like I said, it's a group of up to 4 people, with part 1 being due this Sunday, and then part 2 being due the following Sunday. Actually, it's supposed to be the Sunday after that. I just realized that that is written wrong. So it is actually December 1st. So you get 3 weeks for it. So the overview. Let me dim the lights. It might be a little hard to see it. So, okay. It says up to 3. I am a bad typer. This is why I became a programmer, because I can just use a computer with auto check, but apparently that's not even good enough for me. So again, working in a group up to 4 members, or on your own, and utilizing your cumulative knowledge of the MERN stack. Again, React part is optional, but I mean, it's always encouraged to go above and beyond to continue learning. And you're going to create a web app from one of the following app templates. First option is a survey site. Second option is a bracket tournament web app. And third one is an incident management web app. Your web app must be hosted on a live site that supports Node server. So this is going to be like Heroku. You will have core functionality requirements as well as specific criteria for your type of web app. So there is core functionality that is required in all 3 sites. And where the functionality differs is really the core concepts of what that web app is. All of these are going to require, some sort of login authentication, some sort of like user management, CRUD functionality. But as for the actual how the application functions, what you're going to be doing on the site is, of course, going to differ. So for the common requirements, each web app will share these common requirements. And it's 10 marks. It breaks down. Feel free to read through what each one is for. But the first one is your web app must be designed using well-structured semantic HTML, CSS, JavaScript, and implement a responsive front-end framework. An example being Foundation or Bootstrap, alongside, if you want, again, React.js, along with a dynamic backend. This is where your Node, Express, and MongoDB is going to come in. So your site must be responsive and adapt to various viewport sizes. Again, the reason that I always recommend Foundation or Bootstrap or some sort of front-end CSS library is a lot of it comes out of the box for you if you use like their grid systems. So this is where usually you'll have, say, like 3 grids on a desktop, and then as you shrink down to a mobile view, it's just a single column layout. Again, this is just 2 marks out of it, but it is always a good practice to start to understand using our applications on different devices. I think we as developers very underestimate how much, especially now, mobile phones are being used, because we're very commonly on our computers. But if you start to look at usage statistics across several websites, sorry?
80% mobile.
80% mobile, yeah. It's depending on your site, of course. Yeah, some sites are lower, some are higher. But yeah, it's roughly about 80%. I'd say maybe, I think it was 4 years ago, mobile, no, maybe 4 or 5. mobile had just surpassed desktop usage. So within 4 to 5 years, it's already gained in 30% usability. So if you were to even just build a website, the best thing to do is to make a mobile site and then go to desktop, just because you'll have more users using it on mobile than on desktop. Again, depends on the application. So part B of this is your CSS rules reside in separate files in their own folder and adhere to best practices. You're welcome to use any like Sass, Compass, Less, really whatever you want to use for CSS is fine as long as it works. That's all I ask. I just want it to work. I say that I'm not an artistic person. I'm not a designer. I get that design can be hard, but I like to think that I'm good at it. But this isn't a class where I'm judging your design ability. I just want it to work. So whatever you feel most comfortable doing, if you just want to use CSS, feel free. I always say focus on functionality first, then make it pretty. If you make it pretty and it doesn't work, you don't get marks. Or at least you get less marks. Your JavaScript files, libraries, and other external code are contained in their own folder and are appropriately linked in your site. So if you're using any sort of third-party JavaScript, you're using any like libraries off of NPM, they are in appropriate locations. You don't want to just have it in the root of your folder because organization is good. Because, yeah, I mean, this could be, again, I'm sure every class tells you this, but every project could always be something that you show to a potential employer or a potential co-op. And really, some co-ops might, you just show them the front end and go, here's how it's going. Whereas some other co-ops might say, show me the code. And at the end of the day, if you're not organized, they might not be as interested in working with you because some of us might be coming out here with the exact same skills, and it's really what sets you apart from others. And of course, using Express Generator gives us a nice kind of layout structure. The other thing, it's always recommended to use CDNs wherever you can. In the release of your app, which actually, as of last week, is changing because of how caches work. But yeah, usually using a CDN is good, so that way, if someone uses a script on one site and they come to your site and it's already cached, then they can just reuse that. But that will be, unfortunately, changing.
So what?
So basically, there's kind of like there's an attack that can be used at figuring out who has what cached. So let's say you're an administrator of a fancy site, and only administrators end up caching this specific file. So what a site could do, a third-party site, could try to load this file. And then they do a time attack where they see how long does it take to load this file. And if it's almost instant, then that usually means that that file is cached. So they can then start to figure out who is from a specific site and then use different things on their site to target those users.
Caching of the files?
So the browser is now going to make it so that you can only cache per domain. So let's say you go to google.com and you're loading jQuery. Only google.com will be able to use the cache version of jQuery. If you go to another site that's using the same script, it will have to re-download it, or behind the scenes.
Okay, I understand.
Yeah. Images and multimedia assets are contained in their own folder. Again, this is going to be under our public images folder. You may need to provide additional versions of your multimedia assets to accommodate various viewport sizes. I don't know if they've gone over using different like source sets for images, so that way across different browser widths you can download different images. Again, it's an optimization that isn't necessary. In the real world, you would typically do something like that, but again, this only says you may need to. If it's fine, it's probably, just don't load like 10 megabyte images is really what I always say. All your code, so your HTML, CSS, JavaScript, jQuery, etc., is error-free. This is a big one. If your JavaScript isn't working or your code isn't working, your application probably is not working, so you'll lose marks.
So the MongoDB side, are we still having problems with Mongo Atlas?
I am not aware of any issues with Mongo Atlas.
You're calling out something different there, right? Mongo Lab, Google Cloud Platform, or that.
Oh, yeah. So Mongo used to be called Mongo Lab, and then Mongo Lab actually, they changed their name to MLab, but then Mongo Lab just got bought by Mongo Atlas. That's why we couldn't, yeah. So this is just the equivalent as Mongo Atlas.
Okay, that's fine. I was just making sure you weren't calling for something else.
Yes. So yeah, this is your hosted MongoDB, and I'll just like remove these because I don't. Again, we've gone over in class to using Mongo Atlas, so I don't really recommend using other platforms. But yeah. So number 2, including internal documentation. So I've mentioned this on other things. This is your comments. So including a header comment in your HTML, CSS, and JavaScript that just explains, what the description of the file is, website name, author's name, etc. Including section headers for your HTML and CSS and JavaScript. So this is just to separate different sections of your site. So a comment explaining, nav. Usually I use comments for being able to tell where blocks start and end, because when we start dealing with lots and lots of tags, like I'm talking probably tens of thousands of tags, it can get quite difficult to navigate it in the DOM. So headers are always good. Ensuring all your code uses contextual variable names to make the files more human readable. An example of this would be, instead of just creating var x equals whatever, giving it a normal name. So like tax or tax rate would be more contextual than just giving it a variable name of x. At the end of the day, source code is written by us, so we should understand it more than the computer. And a computer can do a lot more with processing human readable stuff than we can processing computer readable stuff. So that's why we write in JavaScript and not assembly. So also ensure all your that you include inline comments that describe your GUI design and functionality. This is mostly a big thing for when we take code that is online. If we don't understand the code that we copy paste, then we don't actually know if it works, even though we think it works. So really, the big thing is just for functionality. Comment if it's, I always comment something if it's not inherently obvious what it does. This is usually when dealing with edge cases or something that's a more complex problem. I will always throw a comment explaining what the function is doing, either at a specific point or just in general what the function does. Step 3, external document for your web app that includes company logo, table of contents, detailed description of your web app, wireframes that include a wireframe image and appropriate arrows and labels for each page, screen capture section, this will be screenshots of your app, and potential future functionality. So I don't expect this to be incredibly detailed. The external document is required for part 1 and part 2, so you will update it as you go. I always get asked, and this is a common question, is if I haven't built my app, how am I supposed to take screenshots of it? And the answer is you don't. But what is helpful is to create a wireframe of how your application is expected to function with what are called like lo-fi mock-ups of it.
Do you want both a mobile and a Windows version of it?
Not necessary. You're welcome to.
Just curious.
Yeah. I mean, you might not even fully know what it's going to look like on mobile versus desktop. So
No, but I wouldn't do those wireframes until after.
yeah. I always, technically, when you go out into the world, what is typically done is the mock-ups are done before you start building something. If you start to do the wireframes after, then all you're doing is just recreating a low quality version of your site that's already done. So wireframes are nice. You kind of get an idea of how something should work before you build it, which is always good, because if you go in with like a blank canvas, you might kind of go, I don't know what to do.
What are the wireframes due in part 1?
Yes.
Okay, that makes sense.
Yeah. And then the other thing is feature functionality. So this will be a section that describes features that could be added to your app, but you didn't get to. So an example being, let's do the bracket tournament app. So not a requirement of this would be the ability to clone a tournament. So let's pretend, is anyone here a basketball fan? Somewhat? Not really? So hopefully you know basketball, but with basketball, it's always like the same teams that are playing. Not everyone gets to the playoffs, but you might want to be able to clone everyone from the very beginning and start it off brand new without having to enter the same teams over and over again. So being able to use a previous one. So in an example being, for my feature functionality, just talking about, I want to add this feature. I think it would be beneficial because, preventing the amount of data entry, they'd be able to clone a previous one to increase, productivity using the application. So that could be an example of a feature functionality. Lastly, as with every other assignment in lab, you will share your files on GitHub to demonstrate version control best practices and be able to push your site to a cloud host. So your repository must include your code and be well structured. Your repository must include commits that demonstrate the project being updated at different stages of development. So each time a major change is implemented. I encourage you to not just use the upload files to GitHub feature, especially working in a group, just because merge conflicts can happen, as well as, again, it's not what is used in the industry. If you want to get good experience, it's what I highly recommend doing. And then lastly with this, your site must be deployed to Heroku using Git. Any questions about the generic?
On GitHub, are you expecting different people to check in or create commits?
Yes. Yeah, that would be preferred.
So then you have to merge your stuff, your code.
Not always. So, I guess let me try to figure out how to word this. So there are two types. You can do a pull request, and a pull request allows you to take a snapshot of what you have done versus the current site. And then you can merge it in. Another thing.
You still have to merge your changes.
Yes, but the other thing that you can also do is if everyone is working from master, you can just pull and everyone can just push into it. You might get a merge conflict locally, but when you push up, then you can resolve it.
Okay.
But essentially, yes. So app-specific requirements. This is for the survey site. User management and site security. So user registration must be included. A form will allow the user to enter profile information, such as a username, password, email address, etc., which will be stored in the MongoDB database structure. The user will be able to log in, log out, and modify his or her profile. Modify is not completely necessary. In fact, I'll just remove it just because some people usually get stuck on it. But just the user will be able to log in, log out with his or her profile. Site security will prevent any non-registered users from creating a survey or entering secure areas of the site. So this would be, for example, having like a profile section for yourself. And of course, if you're not logged in, then you don't have a profile at that point. Users can create a survey. So after a user is registered and logged in, he or she can create a survey based on one or two possible survey templates. So this would be like a multi-choice, agree or disagree, short answer, etc. So with this, I am not expecting like mix and match. If you're creating a multiple choice survey, all the questions can be multiple choice. It doesn't have to be, oh, I want to create one multiple choice question, two agree and disagree, and then three short answer. If you're just choosing multiple choice, it can just all be multiple choice for simplicity. But of course, if that's what you want to do, then you're free to do so. The user should be able to customize survey questions. So this would be the question that is being asked to the user filling out the survey. So you can think of it as having a title and then having different options that they can choose. So this includes the question text and response options. The user should be able to create a timeline or lifetime for the survey, when the survey becomes active and when it expires. So basically, start and end date, and if the survey is past the end date, then no one is able to fill out the survey anymore. Anonymous users can respond to an active survey. So this means that someone that is not currently logged in. So anonymous users should be able to select an active survey and respond to survey questions. Additionally, survey responses will be stored in the database for later use. So anytime that someone fills out a survey, we want to store that in Mongo, so that way we can do the reporting on it. A registered user will be able to get simple analysis for any survey that he or she owns, including the number of respondents and survey answer statistics. So for the survey answer statistics, this is very, very simple statistics. I'm not expecting, if anyone has ever used Google Analytics, where it gives you a very intense amount of analysis of your website, all I want is 33% answered A, 22% answered B, and 66% answered C. I know that those numbers don't add up, but don't check my math. So for this, just simple statistics and showing the number of respondents. The statistics from each survey should be exported in some manner, so email, printed, export to Excel, etc. Actually, you know what? I'm just going to remove this one, just because that one also usually gets stuck. Really, most times when you make a site, you should just be able to print it, and usually it works. So that's it for the survey site. For option 2 is a tournament bracket site. So same thing, user management on the site, user registration, login, we'll remove the modify again, and the site security of being able to let users post comments in a forum or creating a new topic. So this would be for creating a new tournament bracket. For creating a new tournament, after a user is registered and logged in, he or she can create a new single elimination tournament. Each tournament will have a name and include a short description. When a user creates a tournament, he is considered the owner and can choose when it becomes active and when it is completed. Users can register players. Users can register players by completing a form that includes several player name fields. A fixed number of players will be allowed to be registered. So I suggest probably 8 or 16 players. The reason being is when you have a tournament bracket site, it equals out to being an even amount on either side. And for anyone that is not aware of what I'm referencing, so if I open up a tournament bracket, let me do okay. So in a tournament bracket, you have 2 teams that face off each other, and when one team wins, they continue on, and then we'll face the next team. This honestly does not look the greatest, but hopefully you kind of get the idea of what I'm referencing. Let me try this again, NBA. So here we go, kind of. It's loading. Okay, I am not going to wait on that. But anyway, so a bracket site where 2 teams face off of each other, and then the winning team goes on and then faces the other winning team that is, and continues on until there is just one winner. Let's see. So an active tournament will display a list of users to anonymous users. And depending on the number of players, there will be a fixed number of tournament bouts initially. So 4 bouts for 8 players and 8 for 16. Opponent selection for each bout will be decided in player registration order. So you can make it when you enter in the names. So let's go with 8, for example. And let's pretend that for each team or each name that I enter is just the number. So 1, 2, 3, 4, 5, 6, 7, and 8. So you can make it so that 1 and 2 face each other, and then 3 and 4, and then 5 and 6, and 7 and 8.
But you have to simulate then a win-loss.
Correct. Yes.
And it's a one and done?
Yep. It's just one and done.
Okay.
And then it goes on to the next round.
I don't want to do it, but I tried it, and it was like impossible. The variations and...
Yeah. It honestly, like, all of these have similar properties to each assignment, which is why I'm giving you the option to choose between 3 different ones, is because they do end up implementing similar complexity in each application. They're just handled a little bit differently. So now for the tournament management. So tournament can be started only after all players have been registered and the initial bouts determined. So what this means is when you create a tournament, it's not valid until all players have been entered and it has been started. A tournament will include a fixed number of rounds depending on how many players are registered. 3 rounds for 8 players, 4 for 16, etc. Each tournament round will be displayed as a separate form page. So you will say who won between these two, and you choose the winner for each of the different games that happen. And then you will click submit, and then that will determine who will be playing on the next round. The tournament owner will be able to select the winners for each bout in every round. Only the winners will be carried forward into new bouts for each successive round. When the final round is completed, a summary of the results will be displayed. So this is where you'll display who won, who came in second, etc., etc. So that is it for the tournament bracket. Now, the third option is the incident management site, which I find of the 3 is probably the most boring for myself. But I will say is maybe one of the most commonly selected, because I think students usually think that it might be the easiest of the options. Now, I'm going to also say that I don't think that it's the easiest option, so don't choose this if you think that it is the easiest. I don't necessarily think it's the hardest. I mean, they all have their own complexities, but I just want to give you a forewarning just because some students do choose it thinking it's an easier option. So for incident management, again, same thing. This is copy-pasted between all 3, but C is really the part that really changes. So for the user management, again, registration, login, logout, and we removed modify his or her profile. The site security option is really the part that says that only a logged-in user can create incident records, which are called tickets, change ticket status, posting a comment, or seeing the incident log. And we'll go into what those are. So the incident dashboard, which is the incident log, after a user is registered and logged in, he or she can view an incident dashboard that will display all open incidents or tickets in a clickable list format. So if anyone has ever used like Jira or some sort of like dashboard for managing tickets, hopefully you know what I'm referring to. If not, I'm trying to think of a good example. Do you know any examples of ones that people would probably?
Commercialized ones, but
Yeah, I'm trying to think. So an example, has anyone here ever submitted a ticket, like a support ticket with a company, and then got it, you know, that automated email saying your ticket has been received and we'll get back to you, kind of thing? The other thing is I know, I don't know if the call centers are still popular here for co-ops, but there used to be quite some students that did the call centers here, so usually you'd probably be using a ticket management software as well.
Is the Azure support system. If you have trouble with Azure, you can create a Microsoft ticket.
Okay.
And that's kind of partially.
Yeah.
Because you do get a confirmation email and can track it if you really wanted to.
Okay. Yeah, I'll try to call up an example. Maybe I'll find it on the break just to show off. But yeah, so you're able to see all of the tickets that are in the thing in a clickable list format. So this is all open tickets. The dashboard will include an option that allows the user to create a new incident ticket. So this would be just like a create ticket button. And incidents that are closed will be initially hidden, but an option on the dashboard will allow the user to view all incidents. So a ticket that is no longer open is considered closed, and the user will be able to see those. Creating an incident record. When a new incident is created, when a new incident is created, a form will be displayed that will require the user to select and or complete several fields, including an incident description, incident priority, customer information, and incident narrative. Now, what you do with this is totally up to you. So this would just be maybe just filling in a name and a phone number, maybe some more information. But the incident narrative is basically what happened, why is this ticket being created? So an example being, my laptop isn't working. So that would be the incident narrative. Maybe the priority on that would be kind of low. Maybe my laptop isn't very important. And the customer information would be how to contact me. Email, phone number, name, and then the description as well. So the new incident record will be stored in numerical order, and the incident number will be generated based off of the incident date. So 130418 dash 000001. So in this case, we would do, say if it was today, which is November, so let's do 11. Ooh. And then, oh, today's also the 11th, so that's going to be an awful number to do. 111119 dash 000001. And then the next one, if it was also created today, would become 000002. If we were to create one tomorrow, it would then become 121119 3. So depending on the date that it was created and its number of creation will determine what that incident record number will be. So this is typically the number provided to the customer as a reference. Each incident record or ticket will include an incident narrative that will be timestamped with every status change or incident modification. So you can think of this as the history of the ticket. So if you wanted to go into it, you could see when it was submitted, when it was modified, when it was closed, anything like that. This will provide detailed incident information as well as an audit trail. Each incident record or ticket will also have a status field associated with it. Initially, the status field will be set to new, but you're more than welcome to make as many different statuses as you want. In some systems, you have waiting on customer as an option, waiting for like staff. Usually there's another term for it. I can't think of it right now. But you want to know in the system if the user who submitted it has replied. You need to know, is a staff member supposed to respond to this, or are we still waiting on the customer maybe for more information? Incident management. A registered user can change the status field of an incident by first selecting it on the dashboard and selecting the appropriate status. So some examples is in progress, dispatched, closed, etc. The user must then enter a comment in the incident narrative. So this would be why they're changing it. Once the status of an incident record is set to closed, it will not accept any further modifications. So once it's closed, it's read only. You can't change it. Certain fields will appear grayed out and will not be modifiable. So for example, the incident record number, we don't want them to change it, customer name, incident duration, etc. And every active incident record will include an incident resolution field, which must be filled out before a ticket can be officially closed. So this is different than when you modify something. You want to put into the incident resolution field, what is the reason why this is being closed? So an example, like I said, if my laptop's broken, the resolution would be, we fixed the laptop, or issue is no longer a problem, something like that, that kind of explains why is this being closed? Is it just not an issue, or do we just not like this person? Submitting your work. So the external document will be like an MS Word file, PDF. A couple students last semester also did it just as a README file in their GitHub repository. That's also completely valid. And we don't want that zip. We just want a link to GitHub. Oh, and I guess there's one other thing. Link to Roku. So these are the three things that you need. Your external document, which is going to be, like I said, Microsoft Word or PDF, a link to your GitHub repository, and then also a link to your Heroku instance. The reason why I never really asked for a zip is just because I can download the zip off of GitHub, so there's no point getting you to do it. But just for reference, this assignment is worth 25% of your final mark, and all assignments are due, not at the beginning of class, are due at Sunday at midnight. So 10% deducted for each late day. External code, this is just kind of like the policy that we talked at the beginning of the class, is that any source code that you took online, maybe, what's that called? I can't remember. Stack Overflow. Please cite it if you got it from somewhere, because as I said, we may not always know what the code that we're copying online is. Usually what I find is enough is just put a comment with the link to where you got it on Stack Overflow, because when we, again, as developers go back to work on code, we might not always know why something is there. So being able to reference where we got it from might be beneficial. The other thing is your code must not surpass more than 10% of other code. So using like an NPM module, for instance, to solve our bracket site, not acceptable. We are writing this ourselves to show that we have a working knowledge of using Mongoose and Mongo and all that. So please do not use more than 10%. You must also understand any code. So if for some reason there's something that I feel is beyond your level, I will probably ask you about it. And if you can't answer it.
Back up about NPM, sorry.
Oh, so for example, if you're using other code, like let's say you find a tournament bracket module that handles all the logic for you. I don't want you to use that. Yeah. So you must understand any code that you use and include documentation around the code that explains its function. And you must get written approval from me via email. This is mostly for anything. If you want to do an option that is not chosen here, please just contact me via email. The reason why I ask for written approval for any external code is, like I said, I had students that wanted to just solve the tournament bracket site using an external API, which again is not the purpose of this assignment. So before you do anything that you think you're not supposed to, just check with me first. Like I said, I'm usually pretty good at trying to get back to you. The only thing is usually between the hours of, let's say 5:30 and 8 o'clock. I'm usually driving home, so I might not respond. Shouldn't be responding anyway. So, but that is really it for assignment 2. So I guess quick summary is, again, group project, maximum of 4. You get to choose between 3 options. You don't have to tell me ahead of time. Make sure that it works before it looks pretty. That's really what I would summarize with this. The one thing that I always recommend, and this is for anything even outside of this classroom, is get your cloud hosting and stuff like that working first. So if you do like an Express project, do the Express project, connect it up to MongoDB, and then push it up and get it working on Heroku first, because there's nothing worse than trying to figure out why your connection to MongoDB is not working the night that it's due. So if you do it at the very beginning, you can start to figure out, well, this was working on the first day, and then I did a bunch of new code and now it's not working. So there is something that has happened since the first day that you did it. So that would pretty much be my advice for this. Now, like I said, there's 2 parts to this. There's part 1, which is going to be the first draft of your external documentation and the initial project structure setup. This requires, for the initial project structure setup, is GitHub, Heroku, and I'm trying to think if there's anything outside of that in my head. I think that's really it. The initial project structure is, like I said, the code is on GitHub and it's deployed up to Heroku. That's all you need for the initial project structure setup. And the first draft of your external document. Again, I always split this up into 2 parts, so that way students don't wait until the last minute to do this. This is a big assignment and can sneak up on you very quickly. So please do not wait until 2 or 3 days before. I know when I was a student that I always took that as a challenge and then waited until the last minute. And let's just say it didn't really work out all too well. But I do encourage you to start early. In fact, start tonight. I mean, we're in. What's that? Don't laugh.
I've been up since 7 this morning working. I don't have time.
Wah, wah.
I'm sorry.
Yeah, I've been up since
I
5:30,
know.
so I
But you're
feel
the
you.
instructor. We're the students.
Oh yeah, I'm such an adult. All right. So yeah, so that's it. I'm gonna re-upload this just because I've made some changes to it as we've gone through. But yeah, so initial project structure setup is the GitHub and Heroku, and then the first draft of your external document. Is there any questions about assignment 2? Anything that you're foggy on? Anything that you want some more clarification? Please let me know. Yes.
Are you looking for the basic design for that initial project structure?
Yeah, so that would be like the mock-ups. It doesn't have to be super high level. An example would be wireframes example. So this is a perfect example. So there is a site that why do all these things do that? Come on. Okay, so here's an example of a wireframe of a website. So this is where the logo would go, tagline, here's our navigation bar, image here, image there, text, and then a sidebar. This is
Are you looking for just the home page or for individual?
as many screens as you can do. So the reason why I say as many screens as you can do is as you go to develop the application, you might realize, oh, we need an additional screen here. So an example, I don't expect a different screen for the login and register because they're pretty much the same, right? But I might want, let's take the survey site. So what does the choosing the type of survey look like? And then what does the form filling out the survey look like? And then what does the answering the survey look like? So those are just some example screens. I don't, again, expect everything. And just because you do it in the wireframe does not mean that that's what your site has to look like at the very end. This is just to put your ideas that are mentally up here into something that is able to be seen by your group members. So that way you can figure out how is this website actually going to be working. Does that answer your question? Okay. Anyone else have any other questions that I can hopefully answer?
And then what is the presentation as the last bit?
The presentation is just a research assignment,
Oh,
which is outside of the group project. Well, it's an additional group project, but not related to assignment 2. So that will be researching different packages and then just giving like an overview of what that package is. It'll be like a 5-10 minute presentation,
okay.
but outside the scope of assignment 2. Okay, any other questions?
Is there any way you can make assignment 2, part 2, due the 2nd of December?
The
Or is
second.
December 2nd, the student presentation, oh, that's when it happens? And you need 2 classes for the presentation?
Yes. Yeah, especially just in case if there is a snow day.
No, I understand.
Yeah.
It's just that the person I'm supposed to be working with is not here tonight, so I have no idea how to get hold of him.
Oh, okay, gotcha.
And if you want this done in a week from now, I have no clue if I'm gonna get home, because I don't know what other schools he's in, classes he's in.
Yes. Well, just the part 1. Again, there's not very much code that is required for
I
part
know,
1.
but you want us both to work on it, so I'm saying, I can do part 1.
Yeah, yeah.
And hand it in, but if I can't get a hold of him, I mean, I'm not gonna get
That's-
0 for just because I can't get a hold of the guy.
Yeah, I would say just like do your work, and then if you can't get a hold of him, like just shoot me an email, let me know. Of course, like here's the other thing, I guess not just for people in the room, but for the recording, I understand that this is a group assignment, and sometimes working in a group can be difficult. Of course,
It's a night course,
yes, yeah, that's
right?
it, yeah.
And, you know, oh, sorry, go ahead.
So for this, I understand that sometimes working in a group can be difficult. So what I always say is try to do as much of the assignment as possible that you can do. If you have a group member that either is not pulling their weight or you can't get in contact with them, just do as much of the assignment as you can and just contact me, giving me awareness of what is going on. Again, don't wait until the night before. But just loop me in, let me know. I will try to obviously go a little bit easier on you. And I will not make it so that you and your partner receive the same mark. I expect most people to pull their weight. I don't necessarily think there's any free rides in real life. But I also do understand that, again, this isn't the only class. So if you have a thing with your buddy, you do work in this class and he does work in the other one, so be it. But again, if you feel like you are doing too much work, that your partner is not pulling their weight, please just try to contact me, and I will try to do my best by either reaching out to that student or just making it aware that that student will not be receiving the same mark that you will be.
Do you remember the person who was sitting over there last class?
I'm not very good with
No?
names, no. And you want to what? I went to high school with them.
Did you really?
Yeah.
Oh, jeez.
Yeah, I'm not good with names, so.
Okay, all right.
So, or no, elementary school? I don't know. It was so long ago, I can't even remember. But okay, so that is it for this. So I will be reposting assignment 2 on Blackboard. Submit that.
It's interesting, you already have groups in here.
Is there groups?
Old one, I'm guessing, for assignment 2, group 11, group 2.
Yeah, those don't actually exist. Pretend like they're not there.
Okay. Says what we should have done first, we should have created groups. And then we'd have had everybody's contact
Yes.
information.
So I guess here's the other thing that I forgot to mention. Thank you for bringing that up. So groups on Blackboard, honestly, are the worst. Both from like a student trying to create a group to me trying to mark it as a group. So how this will work is, like, when you submit it, please submit your group members' names in the submission, so that way I know who you worked with. So both their first name, last name, and their student number. The reason for this is so that I can, of course, give all of your group members the mark that they got on the assignment. Just because, again, like Blackboard somehow has the worst group system that I've ever seen. So instead of trying to work with that complicated beast, we're just gonna kind of do like an honor system. Only one person from your group actually has to submit the assignment. But like I said, just put in all the names of the people that are working on it. Okay, so it's 6:57. I'm gonna say that this is close enough to 7 o'clock. So we're gonna go on break for 13 minutes. If you wanna be here at 10 after 7, then we are going to be going over React.js. Now, the other thing, like I said, I know the weather's not the greatest, so if you want to go home now, you can. We are just going to be going over the React documentation, so that way we can start to get our intro into what is React, who is it by, all that sort of stuff. But of course, there's going to be the recording. Fingers crossed that it actually works. But all of this is available online. I'm sure you guys know this by now, being in your final semester of your program, for year 2 anyway. All of this stuff is able to be taught in your own free time. And like I said, React has some really great documentation, so I encourage you to read through it. So, like I said, free to go. You wanted to go over your lab, so yeah, if you need to head out, feel free to do. So, all right. So this is the first day of the final part of MERN, which is React. So previously what we've done is we've done everything server side. So Pug, which is like our HTML of our application, is rendered on the server and then sent back to the user. This would be like the same thing as if we had a hard-coded HTML file and then sent that to the user. What React is it's a front-end framework. So this is being able to manipulate the DOM dynamically, basically reacting to changes in state and being able to reflect those changes in the browser without having to refresh the page. The reason that this became quite popular is, one, I find it quite easy to work with, although it might have a little bit of a steep learning curve at first. But it's it wasn't the first of its kind to do something like this, but it changed the ways that people think about writing for the web. One of the big things that kind of came before it is like Backbone and Angular, for anyone that's used Angular. But React is kind of a thought from Facebook. So obviously many of us hopefully know Facebook, kind of a big company if you haven't heard of it. But Facebook has made a lot of innovation in the tech space. Reason being is it's probably arguably like one of the largest sites out there. So they have a lot of complicated problems that they are constantly trying to solve. Some of those problems that React kind of solves is creating consistent user interfaces across multiple teams. So something that React can do is you can create what is called a component that you can think of almost like our mixins that we were doing in Pug. However, you can reuse these components multiple times across different parts of your application, and it only has to be updated in one spot. But what's nice about this is not just the HTML that is done, but as well as any front-end JavaScript code. So who here, show of hands, has ever worked with jQuery before? Or done anything with like document, like query selector or anything like that? Has anyone mutated the DOM? Like just made a change after, yeah? So what React is really helpful for is instead of manually having to change the DOM, so you don't have to query it and then figure out, oh, did this change? Now I have to update. What it does is it allows you to keep state, and when those state values change, it will automatically change the DOM for us. That way we don't have to do it. So React is a JavaScript library. It's, like I said, it's all front end. And in some ways what's nice about it is you can introduce it incrementally into an application that's already built. But my favorite way to use it is just full-blown React and not even worry about writing anything in Pug. So for trying React, React has been designed from the start for gradual adoption, as I just mentioned, so you can use as little or as much of it as you need. Whether you want to get a taste of React, add some interactivity to a simple HTML page, or start a complex React Power app, the links in this section will help you get started. So there are online playgrounds that you can use to try React. One of my favorite ones is Code Sandbox. It's kind of like CodePen, but way more powerful. But of course, there's CodePen and Glitch, which I've never used before. The other thing is you can just download this HTML file and edit it in your local, as well as there's some other stuff that you can do. So I'm going to skip over the adding React to a site, creating a new React app, CDN links, and release channels. Actually, maybe release channel, no, not as important. That's a newer thing. So the main concepts. So we're going to go from kind of the basics of React to maybe some more advanced stuff, probably next week. So React has this concept of components. So the smallest React example looks like this. So we have this thing called React DOM, and that issues a function called render, and then we pass in an h1 with hello world and document get element by ID root. So what this is doing is saying at there's going to be like a div or something that has an ID of root. I want to render this h1 that says hello world. So it displays a heading saying hello world on the page. Has it tried out on CodePen. So if I open it, you can see hello world. If I change it, the CodePen will rerun. So I'll just say hello example. So CodePen will rerun and say hello example. So nothing fancy. We know how to do an h1 in HTML, but this is manipulating it in JavaScript. So in this guide, we'll be examining the building blocks of React apps, which are elements and components. Once you master them, you can start to create complex apps from small reusable pieces. So this guide is designed for people who prefer learning concepts step by step. If you prefer learning by doing, they do have a practical tutorial that you can use, but we won't be using that today. We're just going to be explaining the concepts, which you might find helpful if you want to do it. Again, if you are interested in this, maybe try doing it in your free time. But like I said, we won't be doing it today. So this is the first chapter in a step-by-step guide about main React concepts. You can find a list of all of its chapters in the navigation on the side right here. If you're reading this from a mobile device, blah, blah, blah. Every chapter in this guide builds on the knowledge introduced in earlier chapters. So you can learn most of React by reading the main concepts guide in the order that they appear in the sidebar. For example, introducing JSX is the next chapter after this one. Knowledge level assumptions. React is a JavaScript library, so we'll assume that you have basic understanding of the JavaScript language. If you don't feel very confident, we recommend you going through a JavaScript tutorial to check your knowledge level and enable you to follow along this guide without getting lost. It might take you between 30 minutes and an hour, but as a result, you won't have to feel like you're learning both React and JavaScript at the same time. So getting started, we're going to go to the next chapter. So introducing JSX. So this funny tag syntax is neither a string nor HTML. So this is called JSX, and it's a syntax extension to JavaScript. We recommend using it with React to describe what the UI should look like. JSX may remind you of a template language, but it comes with the full power of JavaScript. JSX provides React elements, which we will explore rendering them to the DOM in the next section. Below you can find the basics of JSX necessary to get you started. So in here, we are creating an element and assigning this h1 to a variable called element. So at first, you might be like, why would I do this? But under the hood, React recommends using JSX, which gets what's called transpiled. So you might be familiar with the term compiled from your Java class. So you write in a .java file, and then you compile it, and then it gets compiled into a .class file. I think that's right. It's been a long time since I've done Java, to be honest. Yeah, okay. So when you compile a language, it's compiling it on that machine to more like, in this case for the JVM, to read that class file. But because when we're doing transpilation, we're actually converting the source code from one syntax to another. Or sometimes what is like this syntax would not work in regular JavaScript. So what it does is it converts it from this into something else that we will show later on. So why do we do this? So React embraces the fact that rendering logic is inherently coupled with other UI logic. How events are handled, how the state changes over time, and how the data is prepared for display. Instead of artificially separating technologies by putting markup and logic in separate files, React separates concerns with loosely coupled units called components that contain both. It'll come back to components in a further section, but if you're not yet comfortable putting markup in JS, blah, 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 React doesn't require using JSX, but most people find it helpful as a visual aid when working with a UI inside JavaScript code. It also allows React to show more useful errors and warning messages. So embedding expressions in JSX. In the following below, we declare a variable called name, and then use it inside JSX by wrapping it in curly braces. So in here, we have a variable called name. We then create an element which is an H1, and you notice that we have these curly braces right here. This allows us to inject a variable in this spot. So in this case, it would say, hello, Josh Perez, and if we were to render it out, you would see that. But you can put any valid JavaScript expression inside of these curly braces. So for example, you could do 2 + 2, you could do user.firstname if it's an object, you could call a function and passing it a parameter. All are valid JavaScript expressions. In the example below, we embed the result calling a JavaScript function of format name user built into an H1. So this is maybe a lot right at first, but this is basic. We have a format name function. So it accepts what's called user. And then it just returns user.firstname plus a space plus user.lastname. So this is what we would concat to make a full name from both the first name and the last name, something that we've probably done multiple times in JavaScript, and as well as other languages. So we have a const user, which has a first name and a last name. We saw this before. Then we create our element that's an H1 with hello, and then we have the curly braces again that calls a function. So format user, or format name user. And then we have the exclamation mark at the end that's just saying, hello, whatever, exclamation mark. And then we use React DOM to render it. So we split JSX over multiple lines for readability. While it isn't required when doing this, we also recommend wrapping it in parentheses to avoid the pitfalls of automatic semicolon insertion. So in this case, they wrap it like that, so that way it just makes it a little bit easier, more readable, as well as reduces any sort of errors from JavaScript, because of course in JavaScript, semicolons are optional, so it will try to automatically insert it where it thinks it needs it. JSX is an expression too. So after compilation, JSX expressions become regular JavaScript function calls and evaluate to JavaScript objects. So this is, again, a little bit confusing. This means that you can use JSX inside of an if statement and for loops and assign it to variables accepted as arguments and return it from functions. So an example being, we have a function called getGreeting. So we could see if a user is passed as an object. And if it is, then we format and return hello format name user. If it is not passed a user, then we just end up returning hello stranger. Is that making sense so far, kind of? It's just, the main thing that React kind of likes to boast is that it's just JavaScript. So at the end of the day, it's just a function. Specifying attributes with JSX, you may use quotes to specify string literals as attributes. So this is pretty similar to stuff that we've done before. We have an attribute that we're passing 0. You can also use curly braces to embed a JavaScript expression in an attribute. So unlike in HTML, where every attribute has to be a string, in JSX, that is not true. It can be whatever you want. It could be an actual number. It could be a Boolean value. It could be an object, an array. All of these can be passed, and we have to use the curly braces to pass our value. So in this case, it's passing user.avatarURL. Don't put quotes around curly braces when embedding a JavaScript expression in an attribute. You should either use quotes for string values or curly braces for expressions, but not both in the same attribute. And then there's a warning, since JSX is closer to JavaScript than to HTML, React DOM uses camel case property naming conventions instead of HTML attribute names. So this part is maybe, I wouldn't necessarily say confusing, but the word class is a protected name or protected value in JavaScript, because of course we can create a class in JavaScript. So instead of using the class attribute on a component, we actually, if we wanted to pass a class to it, we say class name, which is with a capital N. As well as tab index, which is all lowercase, becomes tab index with a capital I. So this is kind of similar to the way that we use variables in JavaScript, where the first word is usually lowercase, and then every subsequent word is capitalized on the first letter. Specifying children with JSX. So this is kind of similar to if we were doing HTML. If a tag is empty, you can close it immediately with a backslash and then a greater than symbol in XML, like XML or like HTML. So right here, we have an image, and we close it because it doesn't have anything inside of it. But JSX tags can also contain children. So you have a div, and that div has an h1, and it also has an h2, and that is assigned to element. JSX provides injection attacks, so it is safe to embed user input in JSX by default. So in the case of, let's say you're taking user input and someone puts in a malicious script tag. If you were to render it inside of your React, you don't have to worry about it. It will not actually render that script tag unless if you explicitly tell it to, because React escapes any values embedded in JSX before rendering them. This ensures that you can never inject anything that's not explicitly written in your application. Everything is converted to a string before being rendered, which helps prevent cross-site scripting attacks. So by default, you're safe, unless if you decide to do something else. JSX represents objects. So this is, we'll show, yeah. So Babel compiles JSX down to React create element calls. These two examples are identical, and this is more where I'm getting into. So in here we have an element that is an h1 with a class name of greeting, that inside we put hello world, we close that tag, and that's it. This is, except for using class name, we've done this before. Is this foreign to anyone? Just having an h1 seems pretty straightforward. However, this gets transpiled into this function call. So we do react.createElement. So we're creating an h1. This has a property of class name, greeting, kind of similar to when we're doing in Express, when we say like res.render. This is kind of similar. So React would be like our response, and create element is kind of like our render. So in this case, we're saying we want to render an h1, and this is the properties that we want to pass to it. It also has a third option, which is what are called its children, which is the hello world that's right here. So react.createElement performs a few checks to help you write bug-free code, but essentially it creates an object like this. So it creates an object. So we have a type of h1, we have some properties of a class name, some children, and that's it. Hey. Yeah, no worries. Steven was looking for you, but yeah, okay. No worries. So these objects are called React elements. So you can think of them as descriptions of what you want to see on the screen. React reads these objects and uses them to construct the DOM and keep it up to date. And we'll be exploring React elements, rendering them to the DOM in the next section. So before I go any further, the reason why it creates this element is manipulating the DOM, especially in older browsers, can be quite slow. Doing a comparison in JavaScript comparatively to the DOM is much, much faster. So what we can do is do comparisons and keep what is called this virtual DOM. We can create a JavaScript representation of what our markup looks like, do comparisons in JavaScript, and then figure out what we have to change after the fact. The reason that, like, honestly, I'm trying to think of some things that don't use, I guess Svelte doesn't, but most of the front-end frameworks nowadays use virtual DOMs in order to determine what has changed in the DOM. Like I said, because it's fast, and it's a lot faster, especially on like mobile devices. So rendering elements. So elements are the smallest building blocks of a React app. An element describes what you want to see on the screen. So this is like our H1 that says hello world. Unlike browser DOM elements, React elements are plain objects and are cheap to create. React DOM takes care of updating the DOM to match the React elements. So like I said, we have this virtual DOM. We can create an element without even rendering it, and it's not a big deal because we're just allocating memory in JavaScript rather than manipulating any I/O for the DOM. So rendering an element into the DOM. So say we have a div somewhere in your HTML file. We have a div with an ID of root. So we call this the root DOM node because everything inside it will be managed by React DOM. Applications built with just React usually have a single root DOM node. If you're integrating React into an existing app, you may have many isolated root DOM nodes as you like. So to render a React DOM into the root DOM node, pass both to React DOM render. So in this case, we have an element, same as before, an h1 rendering hello world. We then use React DOM render, which accepts two properties. The first one of what we want to render, and the second one saying where we want to render it. And it will display hello world on the page. Updating the rendered element. React elements are immutable. So immutability is a concept of kind of one of the building block, or is the building block of functional programming. But what immutable means is when you change a property, instead of mutating that object directly, it returns a new version of it. So once you create an element, you can't change its children or attributes. An element is like a single frame in a movie. It represents the UI at a certain point in time. If we were to change a property on an element, or sorry, on a component, then it would return a new element. It would end up being, you can think of like it's saying here in a movie, it would be a different frame. So it's completely different than the previous one. It's not the same instance. With our knowledge so far, the only way to update the UI is to create a new element and pass it to React DOM render. So consider this ticking clock example. So it has a function that we create an element. So const element is hello world, and we say what the current time is. Then we do React DOM with that element and pass it into the root. We also do a set interval. And what set interval does is it will run a function for every amount of time in milliseconds that we determine. So in this case, every 1,000 milliseconds, which is 1 second. So we will call this tick function every 1 second. And if I open this in a new tab, so we can see that it's 7:38 with 32 seconds, 33, 34, 35, 36. And if I were to make this a little bit slower, so let's say every 5,000. So nothing happens at the very beginning, and then we're at 49, and then it will be 54, and then 59, and you kind of get the idea. So this is not an ideal way to update because we don't want to have to keep calling React DOM render. We only need to call it once. So in practice, most React apps will only call React DOM render once. In the next sections, we explain how such code gets encapsulated into what are called stateful components. We recommend that you don't skip topics because they build on each other. So here's the main thing about React. React only updates when or what's necessary. So React DOM compares the elements and its children to the previous one and only applies the DOM updates necessary to bring the DOM to the desired state, which you can verify by inspecting the last example with the browser tools. So in this case, we were rendering out an H1 that says hello world, an H2 that says it is, then there's this changing text, and then a period. So you can see that every time that it's updating, the only thing that's changing in the React Dev tools is the actual time that's right here. So even though we create an element describing the whole UI tree on every tick, The only text node whose contents have changed gets updated by React DOM. In our experience, thinking about how the UI should look at any given moment rather than how to change it over time eliminates a whole class of bugs. So you can think of it like, instead of figuring out how should this look in the future, just think of it how it should look now with everything that we know, and React will handle all of that for us. So getting into components and props. So components let you split the UI into independent reusable pieces and think about each piece in isolation. This page provides an introduction to the idea of components, and you can find a detailed component API reference here. So conceptually, components are like JavaScript functions. They accept arbitrary inputs called props and return React elements describing what should appear on the screen. So function and class components. The simplest way to define a component is to write a JavaScript function. So we create a function called welcome that accepts props. And we return an h1 with props.name. So this is basically saying we're accepting an object that is expecting there to be a name attribute. This function is a valid React component because it accepts a single props, which stands for properties. Object arguments with data and returns a React element. We call such components function components because they are literally JavaScript functions. You can also use an ES6 class to define a component, but honestly, I hate working with ES6 classes, which we'll kind of get into why. So these two things are the exact same. This one and this one right here. The above two components are equivalent. Classes have some additional features which they discuss in the next sections. Until then, they're just going to use function components for their conciseness. So rendering a component. Previously, we only rendered React elements that represented DOM tags. However, elements can also represent user-defined components. So instead of using the built-in to HTML like an h1 or a div or an image tag, what we can do is we can create our function that's right here called welcome, and we can call it as a tag like this. So we can call our component called welcome and pass it a name attribute of Sarah. When React sees an element representing a user-defined component, it passes JSX attributes to this component as a single object. We call this object props. For example, this code renders hello Sarah on the page. So I'm going to open this up just to show. So in this case, we have our component called welcome. So I could name this anything that I want. I'm going to call it example and render example right here. And if I wanted to change the name attribute, I'm going to change it to Chris. And maybe I just want to do a first name and last name. So I can do first name equals Chris and last name equals Naismith. And I will render props.firstname and then props.lastname. So I can pass in as many arbitrary props as I want to this component. And as long as I'm passing it in and rendering it, stuff will appear on the page. So an example could be, I could throw in an age. And as I mentioned, you can either do a string value. So I could do a string value like this, or I can actually just pass in a number. So in this case, I'm going to pass it in as a number and say, hello, you are, and then say props.age, years old. And it still renders correctly to the page. So here's a recap of what we've kind of covered. So when we call React DOM render with the welcome name Sarah element, or sorry, let me re-say that. So what's happening here is we call React DOM render with this component that we've created, which is welcome with a name attribute of Sarah, or a name property of Sarah. React calls the welcome component with an object of name Sarah as the props. Our welcome component returns an H1 saying hello Sarah, with the element as the result. React DOM efficiently updates the DOM to match H1, hello Sarah, close H1. Note, always start component names with a capital letter. So React treats components starting with a lowercase letter as DOM tags. For example, a div represents an HTML div tag, but welcome with a capital W represents a component and requires welcome to be in scope. To learn more about the reasoning behind this, you can look at JSX in depth, which we will not be going over. So composing components. Components can refer to other components in their output, which lets us use the same component abstraction for any level of detail. So an example being a button, a form, a dialog, a screen. In React apps, all of these are commonly expressed as components. For example, we can create an app component that renders welcome many times. So in this case, we have welcome name equals Sarah, welcome name equals Cahill, welcome name equals Edith. Typically, React apps have a single app component at the very top. However, if you integrate React into existing apps, you might start bottom up with a small component like button and gradually work your way to the top of the view hierarchy. Extracting components. So don't be afraid to split components into smaller components. For example, consider this comment component. So this is a already, or I wouldn't say already complex, but this has a fair amount of stuff in it. We have one div that has a class name of comment. We then have a second div with a class name of user info. We have another with comment text, comment date. Inside of this user info, we have an avatar. We also have user info dash name. So there's a lot that is to this comment. But depending on what we're doing, we might want to be able to reuse some of these attributes. So an avatar, we might split into its own component called avatar. Likewise, when we bring it in, now it just says avatar that we pass the user information of props.author. After that, we might abstract the user info component that renders an avatar next to the user's name. So we take all of this user info that's right here and we split this into another component. So this would be called user info with a class name of user info. We have a user info name and it also renders an avatar. So in this case, we're expecting there's going to be a user attribute passed to it, and that user attribute is also going to have a name. So now I can render that inside of my comment just as user info and pass the user object to it. As you can see, it kind of starts to simplify our process. Now if we ever want to reuse this user info spot, we can just reuse it inside of our application in a different area and just require it in. Extracting components might seem like grunt work at first, but having a palette of reusable components pays off in a larger app. A good rule of thumb is that if a part of your UI is used several times, for example, a button, a panel, avatar, or is complex enough on its own, for example, app, feed story, comment, it is a good candidate to be a reusable component. And honestly, I'm working on an application right now that I really wish we had some form of component-based architecture inside of it, because we're constantly recreating the exact same CSS and exact same DOM nodes across the application. So I'll show this off right now. So if I go to this website that I'm working on right now, and we go into what are called mentors. So a mentor has a profile photo. So we have their photo, has a name on it, and some attributes for it. This is used in multiple areas. So an example being in a career. So I go into a career, and we now have, oh, not a good one. Let me go into maybe lifestyles. So a lifestyle shows fellow mentors who fit that lifestyle. So here is the exact same component that I'm using, but it's now duplicated in my app. So what would be preferable is if I wanted to say change the design of this, I should only have to change the design in one location. But because now it's in multiple spots of my application, it starts to get a little bit harder. What would be beneficial, like I said, is you just pass it a user attribute, and then it would be able to render out everything, and I only have to change it once. So this is just an example of when we start to reuse parts of our application in multiple areas. This is kind of what I'm talking about. So in React, props are read-only. And again, props are what are passed to a component. So whether you declare a component as a function or a class, it must never modify its own props. So consider this sum function. So this is a function called sum, and it accepts two properties, a and b, and it will return a plus b. So such functions are called pure functions because they do not attempt to change their inputs and always return the same result for the same inputs. So it would be pretty weird if you were using a calculator and you did 5 plus 5 and it returned 10, and then you did it again and it returned 10, and then you did it again and it returned 11. 5 plus 5 does not equal 11. So this is the same idea. A function in React should be considered pure. It should always return the same result if you give it the same properties. In contrast, this function is impure because it changes its own input. So a withdraw function, we have an account and an amount. And that account total is minus the amount. So this is changing a value in a property that is passed to it based off of another property. React is pretty flexible, but it has a single strict rule. All React components must act like pure functions with respect to their props. Of course, application UIs are dynamic and change over time. In the next section, we cover a concept called state, which state allows React components to change their output over time in response to user actions, network responses, and anything else without violating this rule. So you can think of it as you can pass a property of whatever you want, but as soon as you are inside of that, you should never be modifying it. So state and life cycle. This is going to be the last concept that I cover just before the break. So this page introduces the concept of state and life cycle in a React component, which you can find a detailed component here. Consider the ticking clock example that we went over earlier. So how it went about doing it is it used set interval, and then for every 1 second we recalled React DOM render. In this section, we're going to learn how to make the clock component truly reusable and encapsulated. It will set up its own timer and update itself every second. So we can do that by first creating a clock component that accepts props of the date. So this is the date that is passed to it, and we use toLocale time string to render it out. So in this case, we have a clock with date of new date. And then we set interval to tick every 1 second. Again, this is not what we're wanting to do, but this is just abstracting out that clock functionality. It misses a crucial step. The fact that the clock sets up a timer and updates the UI every second should be an implementation detail of the clock. Ideally, we want to write this once and have the clock update itself. So to implement this, we need to add state to the clock component. So notice that we've now removed any properties and we're just rendering out by itself. State is similar to props, but it is private and fully controlled by the component. So converting a function to a class. So you can convert a function component you can convert a function component like clock to a class in 5 steps. It's pretty easy. First, we create an ES6 class with the same name that extends React.component. So this will look pretty familiar to any OOP language that you've used before. We create a class with its name, and it extends from React.component. We then add a single empty method to it called render. So right here, render. move the body of the function into the render method, so in this case returning our element that's right here, and we replace props with this.props in the render body. So right here we change props to this.props because it is no longer a function but an instance of a class. And then we delete the remaining empty function declaration. So why did we just do this? The reason that we do this is so that we can convert it into a class component for it to have state. The render method will be called each time an update happens as long as we render clock into the same DOM node. Only a single instance of the clock class will be used. This lets us use additional features such as local state and life cycle methods. So what does that mean? So adding local state to a class. So we can move the date from props into state in 3 steps. So as we mentioned, we had this.props.state, and we are now converting it to this.state.date. So all we change is this.props to this.state in order to use the state value. So this doesn't exist right now. We then add a constructor. So again, constructors should be familiar from other OOP languages. This is so that way we can create an instance. This is the code that runs when we create a new clock. Because we're extending, we need to call super.props so that way we can create our React component. And then we have this.state, which is just an object. So date equals new date. So this.state.date equals new date. Note how we pass props to the base constructor. So super props, class component should always call the base constructor with props. This is so that way we can set up some basic stuff inside of our React component, which as I mentioned. And then we remove the date prop from the clock element. So we saw this earlier, we removed the property because we are now going to be using state. So we will later add the timer code back to the component itself. So the result looks like this. We have a class component that has a state value of date, and then we end up rendering it out itself. If I open this up, you'll be shocked to see that it looks the exact same, but now it has a state value. I know, not really all that cool, but we will see this in a second. So React has what are called lifecycle methods. And for anyone that has used different types of, has used different stuff in programming, such as like hooks. So sometimes in databases, you might have a hook that's called before insert or after insert, so that you do some sort of code before or after something happens, which is what a lifecycle method is in React. In applications with many components, it's very important to free up resources taken by the components when they're destroyed. We want to set up a timer whenever the clock is rendered to the DOM for the first time. This is called mounting in React. We also want to clear that timer whenever the DOM produced by the clock is removed. This is called unmounting in React. And we can declare special methods on the component class to run code whenever a component mounts or unmounts. So in this case, we have 2 functions that we can call. There's one that's called component did mount, and this is code that is run after we mount the component from React. So this code will run after this has been constructed and after the React DOM render is run. So you can think of it as this is code that runs right after you see it. Then we have component will unmount. And notice the difference between did and will. So they use did to say after something has happened and will to run before something happens. So in this case, component will unmount. This is where we want to remove something before we remove the component. These methods are called lifecycle methods. The component did mount runs after the component, I just said that. Notice how we save the timer ID right on this.timer ID. So in this case, we're creating a set interval that runs a function of this.tick, and we run that in component did mount and set it to this.timer ID. While this.props is set up by React itself and this.state has a special meaning, you're free to add additional fields to the class manually if you need to store something that doesn't participate in the data flow, like a timer ID. We will tear down the timer in component will amount by running clear interval on this.timerID. Finally, we'll implement a method called tick, and the clock component will run every second. So it will use this.setState to schedule updates to the component local state. So one thing that when I started working with React, and I didn't fully get right at the beginning, is you cannot, and this is what I mentioned before, that a component is a pure function. So we don't mutate stuff directly. We don't say this.state.date equals new date every time that we want to do the ticker. So what it does is it calls a function called this.setState, and you pass in the new state values. In this case, it's going to be date, which is a new date. And that's the only thing that's changed here. So note the clock ticks every second. So to quickly recap what's going on, so if I open this up, so you'll now see that it updates every second. What's really handy about this is if we were to change this into something else. So right now a clock, maybe we want to have a different time zone. So let's say we do a div right here, and I'm just going to render 2 clocks just because it's pretty easy to do so. So now I have 2 clocks that are running in parallel, but both of their times are independent of each other. Maybe not the best example to do, but a good example would be if you had multiple counters. So yeah, so using state correctly, these are the 3 things that you should know about set state. So do not modify state directly. This is what I mentioned before. This will not re-render a component. So if you manually set this.state.comment equals to hello, React does not know that the component needs to re-render. That's the thing that React is, of course, made for because of its name. React reacts to state being changed. So if we modify it directly, it doesn't know that something has changed, and it will not update it. So instead we use set state and passing in an object of what needs to be changed. The only place where you assign this.state is the constructor. Second thing is state updates may be asynchronous. So React, if you call set state multiple times, may batch them together for a single update. Because this.props and this.state may be updated asynchronously, you should not rely on their values for calculating the next state. An example being this. So an example, this code may fail to update the counter. So if you take the counter and say this.state.counter plus this.props.increment, this may not be what you need. To fix it, there's a second form of set state that accepts a function rather than an object. This is kind of a more advanced concept that we might not necessarily need to do. Which the function will receive the previous state as the first argument, and the props at the time the update is applied as the second argument. So state and props, so you can take the current state of the counter plus the props of the increment. So this is taking, you can think of it as a snapshot. The moment that that function is run, it will capture the state and the props at that current time. We used an arrow function above, but it also works with a regular function, which you can do right here. And the third thing to know about state is that state updates are merged. When you call set state, React merges the object that you provide into the current state. For example, your state may contain several independent variables. So let's say you have an array of posts and an array of comments. When calling set state, and we pass in posts or comments, it will not overwrite the other values in state, unless if it's like a child of that. So in this case, we have our posts, and when we update it, it will not update the comments or delete it. The merging is shallow, so this.setState comments leaves posts intact, but completely replaces the entire comments. Let's see, maybe last thing before break. Data flows down. Neither parent nor child component can know if a certain component is stateful or stateless, and they shouldn't care whether it is or is not. This is why state is often called local or encapsulated. It is not accessible to any component other than the one that owns and sets it. A component may choose to pass its state down as props to its child components. So in this case, we have an element, and we're just rendering out the date as like in our clock. This also works for user-defined components. So in this case, we have a formatted date, and we pass in the date of the state. The formatted date component would receive the date in its props and wouldn't know whether it came from the clock state or the clock's props or was typed by hand. There's no way of knowing that this value that's right here is coming from state, props, or just typed like it's hard-coded. Because, and this is what I'm saying with pure functions, that it shouldn't matter. The only thing that this formatted date should do is render out the date that is passed to it to locale time string. That's all that matters. This is commonly called a top-down or unidirectional data flow. Any state is always owned by some specific component, and any data or UI derived from that state can only affect components below them. So this is basically saying that unless explicitly told, a child can never modify a parent. If you imagine a component tree as a waterfall of props, each component state is like an additional water source that joins it at an arbitrary point but also flows down. To show that all components are truly isolated, we can create an app component that renders 3 clocks, which is what I did before, and all of them are separate from each other. So this is the end of state and life cycle. We're going to go on break for 10 more minutes. So if you want to be here at 8:17, then we will be going over a couple more things, which is just handling events. The main thing that I always find with React is going over the documentation. It's hard to understand the positives and pros of using React until you start playing with it and realize the benefits of working with it. So we're going to leave it here. If you want to be here, like I said, 8:17, then we'll continue this.
After that, you can.
Yep. Okay, so the next couple things that I'm going to be going over is just handling events and conditional rendering. Those are going to be the last two things that I'm going to be going over tonight. So in React, the only thing that we've done right now is we've used a timer to change a state value every 1 second. The other thing that we've also seen is the ability to pass in a property. So what React can do, just because it's JavaScript in general, we can handle events. So this could be like a click event or a submission of a form. And handling events with React elements is pretty similar to handling them on DOM elements. There are some syntactic differences though. So React elements are named using camel case, just like everything else, rather than lowercase. And with JSX, you pass a function as the event handler rather than a string. So an example of HTML would be we have a button with an on click of this would be a function that we're calling. But in React, we would say button on click. Notice the capital C on click, and we pass in the function of activate lasers. Another difference is that you cannot return false to prevent default behavior in React. You must call prevent default explicitly. For example, with plain HTML, to prevent the default link behavior of opening a new page, you can write return false right here. However, in React, you would create a function called handle click that would call e.prevent default and then console log the link was clicked. We then pass that function to the on click property. In here, E is the synthetic event. Or sorry, E is a synthetic event. So React defines these synthetic events according to the W3C spec. So this is basically who's responsible for the web on what is an event in HTML. So you don't need to worry about cross-browser compatibility, and you can see the synthetic event reference guide to learn more. Not important for what we're doing right now. When using React, you should generally not need to call add event listener to add listeners to a DOM element after it's been created. Instead, you can just provide a listener when the element is initially rendered. So when you define a component with an ES6 class, a common pattern is for an event handler to be a method on the class. For example, this toggle component renders a button that lets the user toggle between on and off. So as before with our clock, we have a class called toggle, which extends React.component. We have a constructor that calls superprops. We have this.state, which has a value of is toggled on as true. And then we have this.handleClick, which is we're binding to this. And all this does is we set is toggled on to its opposite value. So true becomes false, and then false becomes true. So we have a button that has onClick equals this.handleClick. So every time that we click this button, it will run this function of handleClick and change the value of is toggled on to its opposite value. Then we end up rendering, and we do a check. If this.state.is toggled on is true, then we end up rendering on as a string value. Otherwise, meaning that is toggled on is false, we end up rendering off. You have to be careful about the meaning of this in JSX callbacks. So in JavaScript, class methods are not bound by default. I don't know who decided that that was a good idea. I think like looking back, they should be shot because like that is a bad idea. So in JavaScript, you can bind the context of this, which honestly, like, it is a huge headache. But as of modern stuff, like so here's the thing. If you're already able to do an ES6 class, you can already use arrow functions. And when you use an arrow function, it will automatically bind this to it. So an example being here. So this is using even more modern day syntax called the public class field syntax. And what this does is we create a function using the arrow syntax, and this automatically binds the context of this to that function. The reason that this happens is you can kind of think of it like if we don't explicitly say, if we don't bind this, you can think of it like a static function. It doesn't know the context of itself. And unless if we bind it, then it becomes, like quote, self-aware. It becomes aware of its own instance, and then it can change properties of that instance. So this syntax is enabled by default in Create React App, which is probably one of the easiest ways to actually start working on a React application. If you aren't using the class field syntax, you can use an arrow function in the callback like this. The problem with this syntax is that a different callback is created each time the logging button renders. In most cases, this is fine. However, if this callback is passed as a prop to lower components, those components might do an extra re-rendering. We generally recommend binding in the constructor or using the class field syntax to avoid this sort of performance problem. Passing arguments to event handlers. Inside a loop, it is common to want to pass an extra parameter to an event handler. For example, if ID is the row ID, either of the following would work. So in this case, we have an onClick that we have the event, and we do this.delete row, and we have an ID, and then the event. The other option that you can do is do this.delete row.bind this comma ID. The above two lines are equivalent, and the use arrow function and function prototype bind respectively. I would probably go with the arrow function as I find it more clear on what's going on, but honestly, it doesn't really matter. In both cases, the E argument representing the React event will be passed as a second argument after the ID. With an arrow function, we have to pass it explicitly, but with the bind, any further arguments are automatically forwarded. So because we have this ID right here, anything else that was going to be passed will happen after the ID, so it goes ID E. And that's really it for handling events. So we obviously, in next week's class and the week after that, will be going more into actually creating some reactive programming using React. Again, this is just kind of getting the core concepts of how it works. Last thing is conditional rendering. So in React, you can create distinct components that encapsulate behavior you need. Then you can render only some of it depending on the state of your application. So conditional rendering in React works the same way conditions work in JavaScript. Use JavaScript operators like if or the conditional operator to create elements representing the current state and let React update the UI to match them. Consider these two components. So you have user greeting, which accepts props, and then guest greeting, which also accepts props. We'll create a greeting component that displays either of these components depending on whether a user is logged in. So we could have a wrapper around both user greeting and guest greeting that is just called greeting. So it accepts props, and we check if they're logged in. And if they are, then we return the user greeting. Otherwise, we end up returning the guest greeting. This example renders a different greeting depending on the value of the isLoggedIn prop, which you can see is right here. So isLoggedIn equals false. So in this case, because isLoggedIn is false, this bit of code right here where we render the user greeting would not be rendered. It would end up returning the guest greeting. Element variables are also other ways to store elements. This can help you conditionally render a part of the component while the rest of the output doesn't change. Consider these two new components representing log out and log in buttons. So we have a login button, which is just a button with an on-click event. And we have a log out button that does the exact same thing. It has a on-click event and it says log out. In the example below, we will create a stateful component called login control. It will render either the login or the logout button, depending on its current state. It will also render a greeting from the previous example. So this is starting to get more complex, but you can see that we have these two functions which are binded. where we have a handle login click, which sets is logged in to true. And then we have a handle log out click, which sets logged in to false. So because we have a state value of is logged in, by default, it is false. So let me open this up right here. So we have a component called greeting, which we saw before, and then we end up checking the button. So we're creating a variable called button, and if we're logged in, we're going to assign it to the logout button, and then its on click is going to be this handle logout click. Otherwise, our button is going to be the login button, and it's going to log us in. While declaring a variable and using an if statement is a fine way to conditionally render a component, sometimes you want to use a shorter syntax, and there are a few ways to inline conditions in JSX, which are explained below. So I'm going to show you this element first. So I zoom out a bit. So you can see we have our button that says login. If I click it, it says welcome back, and it has now changed it to log out. So both of these have now changed just from the state right here being updated. So if I click log out, both of them get changed again. So if I wanted to swap it for, let's do something else. I could end up doing a check of is logged in, and if we are, then I'm just going to render example. So I'm not logged in, I click login, example, and then I log out and it's gone again. So that's what we can do with what is called the inline, like we can do inline if with logical ampersand operator. So in JavaScript, which honestly, like some people might not like this syntax, when we do an if statement, there's what is called short circuiting. So an example being we have an if statement where we're checking two properties. So let's say we have is logged in, and let's see. So if we're logged in and they're in a specific group. So we would have an if statement. Let me actually open this up in my editor. So if we have an if statement that says is logged in, and let's say user.group equals admin. So okay, so this is an if statement that's checking if I'm logged in and my user.group is admin. So if is logged in is false, it doesn't actually check my user group. And the reason for this is short circuiting, because I'm checking if is logged in is true, and if it evaluates to false, it doesn't need to check anything else. So in JavaScript, we can actually use that feature in order to conditionally render something. So in here we do unread messages.length is greater than 0, double and then we put in an element. So what this is doing is kind of like an if statement of checking if unread messages.length is greater than 0, then I want to render this h2. But we use the double ampersand in order to only render this if the length is greater than 0. We can also use the, well, we can also do if else with a conditional operator. So hopefully you should be familiar with a ternary operator, which is kind of like a inline if statement. So how a ternary operator works is the first condition is a Boolean statement, kind of like an if statement. So if the condition evaluates to true, then whatever is after the question mark will happen. So it could be like a function call. It could just be a value if you're wanting to render something out. You could do an operation. Anything, you know, that's valid JavaScript will happen in between the question mark and the colon if the condition is true. If that condition ends up evaluating to false, then anything after the semicolon will be run. So in the example below, we use it to conditionally render a small block of text. So if they're logged in, then we end up rendering currently. If they are not logged in, then we end up rendering not. It can also be used for larger expressions, although it is less obvious of what's going on. In this case, we have is logged in, question mark, and we display the logout button. Otherwise, we do the login button. But just like in JavaScript, it's up to you to choose an appropriate style based on what you and your team consider more readable. Also remember that whenever conditions become too complex, it might be a good time to extract a component. So if your logic starts to get too confusing, sometimes it's a better idea to just make a new component. Preventing a component from rendering is another part of conditional rendering. In a rare case, you might want a component to hide itself even though it was rendered by another component. All you have to do is return null instead of its render output. In the example below, the warning banner is rendered depending on the value of the prop called warn. If the value of the prop is false, then the component does not render. So in this case, it just does a check. If there's no props.warn, it just returns null, which means that it's not going to render anything to the DOM. It's not an empty div. It's not a text value. It literally just does not render anything. Otherwise, it will render a div of class name warning, and then it renders it here. Returning null from a component's render method does not affect the firing of the component's lifecycle methods. For example, component.update will still be called. And this is important to know because when we are rendering nothing to the screen, technically it's still updating. So we can end up using it in other ways. An example being handling code that is going to fire stuff for us, but doesn't actually render anything to the screen. I'm going to say that is it for tonight. Some of the more, and it's not even getting into the advanced part, but going over lists and keys. A list is just, it's an array. So how can we start working with arrays? Forms, lifting state up is when we start moving state from one component into a parent and then passing it back down. These are things that we'll kind of get into as we start working with it. Composition versus inheritance, and then thinking in React. So, and I said this at the beginning of class, like, to me, I would say, and you want to what? Like, I'd say I'm biased in React. I think that React is probably one of the most employable technologies that you can learn right now. I showed this off last semester. Let's see if I can find it. So this was here we go. So it's a Medium article that is of different companies in the Bay Area that are using React. And I certainly hope that most of these companies you would recognize. So Adobe, AdRoll, Airbnb, let's see if there's any, App Academy, Bitbucket, let's see what else, Capital One, Cloudflare, Coursera, Code Academy, Datadog, Discord, Docker, Discus, DocuSign, eBay, Dropbox, Eventbrite, Facebook, Grammarly, Imgur, Instacart, Indeed, Intuit, Khan Academy, Lyft, what else? Netflix, Oracle, Pinterest, PayPal, Postman, Postmates, Prezi, Reddit, Remind, Salesforce, Rollbar, Sentry, Shopify is a big one. I'd say probably actually the two biggest outside of like the Facebook ecosystem, I'd say would be like Airbnb and Netflix are two of the biggest ones. Stripe, Tesla, Teespring, Twitch, Twitter. Uber is also another big one. Udacity, WeWork, Walmart, Workday, Zendesk. Like, honestly, like, this is clearly a huge, huge list. And like, these are some of the most valuable tech companies in the world. And what I say is, like, Facebook obviously has a completely different problem than you or I are probably trying to solve on a daily basis. But the fact that there are so many diverse companies in so many different areas of technology, like anywhere from Tesla that's trying to do, self-driving, and really they're probably using React for the interfaces inside of the self-driving car. So being able to, change the temperature of the air conditioner, to Walmart, Airbnb, like all of these companies are obviously all trying to solve different things. And the fact that they all, at least for right now, agree upon using React, I think signifies how powerful of a technology that it is, and showing how employable that technology is. Because if really, in theory, if you know these technologies that we're covering in school, but also knowing React, like, this is something that could, in theory, get you employed in some of these top, 100 tech companies. So, and to just, I guess, to finish off before I let you guys go, like, this is not, I'm not saying that React is the be all end all. I mean, in 5-10 years, there might be something else that's out there. And just by knowing React doesn't mean that you're going to get a job. But this is a technology that is in high demand and is still rapidly growing. And I mean, let's put it this way, like, there's tons of WordPress that is out there. I think 56% of the internet is still WordPress sites. So there's still knowledge in knowing old technologies or older technologies, but I don't think React is going anywhere soon. And I think as time goes on, there's still going to be bigger companies that are going to be starting to look at it, because large companies don't want to just take a new technology that disappears a year from now, because they're looking to invest in a technology for 5, 10, 20 years. So if this is something that interests you, if you want to have very employable skills to either use in the Barrie market, the Toronto market, the global market, I would say React would probably be like the number one thing to invest your time in. So without that, that's the end of class. I will see you guys next week. Please do not forget about assignment 2, part 1. Groups are a maximum of 4, and the beginning of just the internal documentation, the GitHub and Heroku link, are due this Sunday. So, yeah, hope you guys have a good week.